Okay. Okay, so obviously you realize that if you have any trouble with factoring, you're going to hate a lot of the problems in this section because it's so if you have trouble with factoring, that's bad. At this point, you shouldn't have any trouble with factoring. In fact, we're going to learn some new ways to factor much more complicated expressions that are factorable. One of them is called synthetic division. So I don't know if anybody's ever heard of that. Synthetic division kicks ass. So if you're at all worried about or heard bad things, don't talk to those people anymore. They
Takes
don't
up a
know.
whole page.
Huh? Took a whole page? What? Alright, you guys are good. Let's see. So the first step here, end behavior, I don't really do anything to it. I can see it. What's the end behavior going to be? Yeah, so it's x to the fourth. So it's going to be to factor this thing, first you got to take out
X squared.
X squared. And then
X plus 5, X minus 2.
so you know the intercepts, the zeros, that's another name for the intercepts. I could also say the roots.
0, 0.
0, 0.
Negative 5, 0.
Yeah, good. Negative 5, 0.
And 2, 0.
2, 0.
And then y-intercept 0, 0.
Yeah, y-intercept, if we're listed that good. 0, 0. Kick ass.
You don't care if I don't write it again if I already have it on there,
You're
right?
fine. Just be careful when I say find the intercepts. If I just say find the intercepts, it means all the x-intercepts and the y-intercepts. Why is there always just one y-intercept?
Because it's a function.
Yeah, it's a function we're going to be working with, so can't go against the vertical axis. Now you could do this, and it's not a bad idea if you like the multiplicities, because the multiplicities make this pretty quick. Because it's really, I don't ask you to do this, but it's a really good idea. Well, actually, I just did it. That kicks ass. I'm glad I did it. Sketch an incredibly rough sketch of the shape of the function, like I did over there. So I could put on here the 0, 0, 2, negative 5. Now the only one that is multiplicity of even degree.
So X squared.
Yeah, it's x squared. So that's going to be the 0. It's going to stay the same sign on both sides. Let me try to do the shortcut. If I put 1 in there, I get positive, positive, negative. Yes, sir.
What? If you already know it's because you know the endpoint, it's going to go up.
Yeah.
I know.
Okay.
I'm showing more work than absolutely necessary. The more comfortable some of you guys get, the less you got to do. Yes?
Is that just a z above those? I don't get confused.
Those are just z's, yeah. Because when we start plotting rational expressions, rational functions, some of them will be used because they'll be undefined. Yeah. So if I do plug in a 1, I get positive and negative. So that means on this side it's also got to be
Negative.
and then on the other it's got to change to plus. Cool. I like it. And like Brian said, this kind of goes along with the fact that I know it's got to be up here at the ends. So thank God I got positive on both sides, right? We can use that to start this thing off. So if I want to sketch a rough sketch, it starts positive, goes through 0, then it's negative, touches 0, and then goes through 0, so it looks like that. Right? Good old butt rock. Just to get that out of the way now. Blah, 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 blah. Okay, that's all we gotta do there. So part D is where I try to bring everything together. So the first thing I do is, what do I do?
Plot the zeros.
Yeah, plot the zeros. Good, so 0, 0, negative 5, 0, 2, 0. So my x scale normally is, I know what it's got to be, so I can fit all the roots in. The y scale is what I'm not too sure about, and I can see from my rough sketch what I want. I definitely want to plug in 1, so I want to figure out what f of 1 is.
Maybe 2.
Maybe negative 2 or negative 3. Either one you feel like, or even negative 2.5 if you feel like doing that. So f of 1 would be, if we put it up here, 1 plus 3 minus 10,
6.
negative 6.
Negative 6.
And f of negative 2 would be 16 minus 24 is negative 8. Minus 40. Did I do that right? Negative 48? Sweet. Alright, so are you guys with? Do you guys see how I determined what to plug in? Sometimes I'm nice and I tell you, find f of 3, f of 4, because that'll help you. But don't bank on that. Alright. So then I know my scale, I want it to be
12.
Sure, I like it. So I want to be able to fit this on there. So if I go 12, 12, 24, 36, so forth, then in negative 12. It doesn't matter what the scale is as long as it ends up fitting
Everything.
everything that you need in there, right? And as long as it's consistent.
So you can go by 100 on this one?
Yeah, and as long as it's good enough to show me what the hell's going on. If your graph ends up looking like this, it's probably not good enough, right? You probably want to blow that thing up. Okay, so now I've got my my y-intercept is what? 0, 0, I already got that. My f of 1 is negative 6. That's beautiful, so it's right in the middle. And f of negative 2 is negative 48. Bam. So my end behavior tells me to start up. So I'm coming down here, then I go through. I forgot, I can put on here if I want to. It's through, turn, through. So you guys might realize it's a lot like the last one we did, just so we felt a little more comfortable doing this. So down we go through, catch this guy, turn. So I turn there, get through this guy, and then through there. Bam.
You know, if you plot those other ones like negative 3, it drops down to negative 90.
Oh yeah, okay, good.
Yeah, it goes
All right.
crazy far.
So it goes way down here. Okay, good. But I'm gonna give yourself something in the middle here to figure out about where this goes. And this is what I mean. This is a rough sketch by hand. So if you happen to pick negative 3, it goes down to 90. So then your picture would look more like that. Right, we could do a lot further down. But it doesn't really matter at the end of the day. It's just capturing the idea that this does go pretty deep. I want to say one more thing. Oh, I forget. Shoot, I forgot. So anything about that? If you graph this in the graph calculator, it should pretty much match up with that. Especially you make your y mix min and max match with the scale you used in your own graph. It's a really good idea. All right. Okay. And real quick, just to show you what I'm talking about, here it is on the graphing calculator without changing the window. Before I trip and kill myself. So if I change the window a bit to, where we go? Yeah, I did this piece by 5, right? So negative 5 to 5 on the x-axis. And I did mine, let's make this negative 60 to 60. Coolness. And there's capturing the fact that it goes down to 90, right? In between here. That's kind of what. Mm-hmm. So if you check yourself in the graph and you see it going deeper than what you thought, it's okay. Don't change anything. You're fine. The work you did is represented on your graph. That's what I want to see. Cool. Okay, good. So I want to give us a little motivation for the next section. Obviously, the first step on this is the One of the first steps is factoring it. So we have to learn more powerful ways to factor because there's a lot of functions we cannot factor that are actually factorable. So, for example, I'm going to start off with the most disgusting way to do this, which is long division. Thank you. Let me pick one out that actually works.
How much room do we need for this?
What's that?
How much room do we need to take for this?
Yeah, we'll see. Let's see. There we go. Thank you. Is that right? Sweet.
Is this still part of 3-2 here?
This is 3-3. 3-2 is basically everything we did on that handout. So, if I ask you to long divide this, yes?
Is this sort of like you sort of get a remainder?
Possibly. You don't want a remainder. It's just coming back. So you want the remainder to be 0, which means whatever you pick to divide this by went in evenly. So that's why it would be a way to factor. Now, one thing I want to point out. So if I do factor this maybe this will come out to, how many of these could it possibly come out to be? 4. This is a 4th. I love it. And these would all be x. Now it might not. There might be something that I can't break down further. It might go into complex numbers, but it would be a squared. It would still be a 4th degree at the end. So the numbers at the end here, these numbers here, they all have to do what? It's a really weird open question, I know, but how did I know to put x, 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 x?
They end up to 4.
So at the end,
They have to add up to 10.
they all have to multiply to be 10, because I'm multiplying when I FOIL it out, right? So I could try to divide this thing by, for example, what could one of these be?
1.
It could be 1, so it could be x minus 1, or x plus 1, or x minus 2, or x plus 2, or what else? 5 or 10, right? How are we doing so far? So that's where synthetic division is going to help us out, because long division is kind of, it's appropriately named. It's freaking long, right? There's a lot of excess crap that you really, really don't need. So if I make you long divide, I'm going to tell you what to divide by, just so you can prove to me that you can long divide. Are you with me? I'm not going to leave it open, because my God, if that was a 60, how many things might you have to try? A lot. And if you're not lucky, you're going to try every damn thing before. And you're going to, on the way, you're going to go insane and kill people. And I don't want to do that to anybody. So, let's do this. Go ahead and show me you can do this. Divide this by x minus 5. I'm assuming you guys have all done long division before. That might be too big of an assumption. So let's do this together.
I'm really confused.
Oops. When you say you're really confused, are you confused about what I talked about here?
No, I'm confused on how the hell do you divide that.
Okay, good. We're going to do that right now. So it's okay to be confused, because we're going to talk about it. All right, now remind me real quick on the side here. What really sucks is if anybody is from a country where you don't divide like this. Every now and again, somebody shows me that way again. I'm just so not used to it that I remember it for a little while and then it's out of my head. So I don't know if anybody divides things differently. So if I divided 7 into 512, I'd set it out like that. Whereas in other countries, they set it up differently. It's kind of neat. And of course, we're like, how else could you set it up? We're so used to this. But of course, there's a billion ways you can really set this up, really. This is just one way we picked and we're just used to it. So if you have any trouble with that, let me know. Eventually. Okay. And so let's just go through a couple steps here. Just remember long division. 7 goes into
7.
and then what do you do? Whatever you put there, you multiply by this. You put the result there, and then you change the sign. I like it. And you combine these.
Yeah.
Right?
22.
Then you bring the 2 down.
3.
3.
21.
21. Change the sign. And then you do plus 1/7. And of course, we don't normally show the plus, but we know it's there. That's what a mixed number is, right? All right, so since variables are numbers that I don't know yet, they have to do everything numbers do exactly the same way, believe it or not.
Right.
So here, and now real quick, just go with me for a second, just to really show you why we do it the way we do. If I had this problem, it doesn't matter, Jeff. What would be the first step? What would you really look at?
What setting could you go in the
Do
first?
you look at 72? No, I look at 7 and 51 really. I know I'm going into 519, but I'm going to try what? 7 goes into 51?
4. 7 times.
You guys got it? So I kind of ignore, I know this is 70 plus 2. So I kind of ignore this guy at first and I just looked at him to get me started. Are you with me? So here we ignore this dude at first. X goes into x to the 4th.
4 times.
Good. Say what?
3 times.
Right, x times x cubed is x to the 4th, you with me? And then what do you do? So you put a number up here, then you multiply x to the 4th.
Oh. Wow.
All right, let me do it again. So we're all cool with x cubed sitting there, right?
Yes.
Then what do you do with this? You multiply this by this. That's exactly what we would do here next, right? I don't care that I ignored the 2 to begin with. I have to multiply 7 by 72. So I got to multiply this by x minus 5 and put the result here. X cubed times x. X4. X cubed times negative 5.
Negative 5 cubed.
And before I combine those, I
Change the sign.
change the sign. You see why I said it like that now, right? Subtracting an expression is changing the signs of that expression. This is familiar to anybody? Some of you guys have done this. And some of you guys, it's somewhere in there. And then here, of course, nifty things happen. Good. And then you bring this guy down. And you might as well bring this guy down too. I don't know if you guys see why. This is 2 terms, so I'm going to result in 2 terms later. Even if you miss that, it'll eventually come out. So now x goes into negative 5x squared.
Negative 5.
Yeah, I need a negative 5 and I need another x. Negative 5x. What's up? Let me say it a different way. X times what is negative 5x squared? X times negative 5x is negative 5x squared. Right? So then that times that is this. That tells you you're on the right track. These always have to cancel out. Negative 5x times negative 5. And then you change the signs.
That's like magic.
Negative 2x.
If you like this, just wait till we learn synthetic. That'll really be magic. If you know synthetic, you know what I'm talking about. If you don't, you'll see. And then minus 10 down. Good. So then the x needs a negative 2, so negative 2x. Negative 2 times negative 5 is? Drop it. Drop it like a microphone. And then
Positive
change
change
the
sign.
sign. Well, she did. She was like, I'm done. Bam, bam. Now, what does that mean? That means that this factors, the first step of factoring would be, what? How does it factor?
Take out an x minus 5.
This times this. I love it. And what's really, really nice is I have to do it again, don't I? If I wanted to keep going, which we're not. But I don't have as many possibilities. It's only a 2 at the end. So it'd be plus or minus 1 or plus or minus 2 that I could try to divide it by. You guys kind of with me? Because first step, I divided by basically 5. So that cut down my possibilities for the next step, thank God. My list of things to try is not so big.
So if
Yes,
I-
ma'am.
How did you know what to divide it by?
The complete list, is it cool? X4 is x, 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 x. 10 could be 1 plus or minus 2 plus or minus 5 plus or minus 10. So I'm going to divide it by one of those things. And I told you, if I'm going to make you long divide, I am not going to make you guess. I'm going to tell you what to divide by. When we learn synthetic division would do this problem in like 1/5 the time. So maybe I should just show it to you now. And maybe that'll be where we stop. So let me show you synthetic. This is sort of getting into the next section, but I might as well show you now because it takes this process and makes it much easier. The one thing about synthetic is it only works when you have one x plus number. When you have a linear thing you're dividing by with a 1 in front. Are you guys kind of with me?
Mm-hmm.
So if I was dividing by 2x minus 1,
No.
I could just do this and still do what I'm about to do.
Okay.
Divide by this instead. And then whatever I get, I got to divide it by.
You gotta divide it by 2 and
So you can still, anytime it's linear that you're dividing by, you can make synthetic division work. But if I was dividing by 2x squared minus 1, there's a way around it, but you're basically screwed. You have to do long division. You guys kind of, so I want to make that really clear. The process I'm about to show you, which is called synthetic division, requires the thing that I'm dividing by to be linear. Even more restrictive, it's got to be 1 in front, but if it's not a 1, I can make it that way, right? Just factor out whatever the whole number is. So we're going to do this problem, but we're going to use synthetic division, which sounds, I play tennis, so it sounds like synthetic strings or something. It's really weird. Synthetic division. Okay, here's what synthetic division does. See how this piece here, every time, why? Why would we do that? That's stupid. I don't need this because I know it's going to cancel. So synthetic says, I want to find a way to focus on what's really important. These numbers are what's really important. And since I'm dividing by something that has a 1 here, whatever this is going to be what I put here, isn't it? So that's all kind of built in. It takes all the stuff out of the way that doesn't matter. So here's what I do. If I divide by x minus 5, I don't really watch hockey, but I call this a penalty box. In the penalty box, like, you go with me. If you've never seen this before, you got to see it a few times before you get how it works. Trust me, but it's so stupid fast. Another stupid thing about this is having to change the sign every damn time, right? To change the sign. If I forget to change the sign, the whole thing is just screwed. So what synthetic division does is if you divide it by x minus 5, change the stupid sign right off the bat. So effectively, you're putting the 0 of that in here, right? You've changed the sign already. You guys semi with me? Now, as long as this thing is in order and isn't missing anything, if it was missing something, there would be a 0 there, right? Mm-hmm. What really matters, as long as this is in descending order, what really matters are the numbers, the coefficients. So write down the numbers. It'll be 1, -5, -5, 23, 10. Okay, how are we doing so far?
Good.
So what synthetic division does, it changes the sign right off the bat. It focuses on only what's important. Obviously, this has got to be in order, and you have to fill in any gaps with zeros before you write those down, and then synthetic is good. So this very first dude, why was this a 1 here? Because it was a 1 here, right? If this would have been a 2, wouldn't this have been a 2?
Yeah.
So watch, that's why the first step is, whatever this number is, drop it down. This is going to be my answer down here. It's going to be the coefficients of my answer. And then watch what you do. What did I do here? When that was a 1, I multiplied these together, right?
Mm-hmm.
So I multiplied 5 times 1 is 5. Add. See, there's my -5, 5.
So there's a 0.
For 0.
0 times 5 is
0.
0. Add. So that's really this piece here. Then
5 times
-5 is -25. And there's your 23, 25, right? So synthetic only allows the most important stuff to show up. So I get, and then 5 times -2. And this is what you were talking about. Somebody over this general direction. No remainder, right? Whatever number is at the end is the remainder term. So I know I'm in a good track if that's a 0.
But if you get a number there, do you have to put it like over? Whatever
Yes, good, exactly. If I would have gotten a number like 2 here, I would have had to say plus 2 over x minus 5. The same way we had to say this with numbers. It works the same way. So how do I read this? Well, this was a what degree?
4.
So if I divide by basically x, I should end up with a
Third.
third degree. So this is 1x cubed, no x squares, 5x, 2. That's exactly what we got, right?
Bam.
Synthetic takes so much x. Second?
Explain that part again with the x cubed and...
This whole process is dividing a 4th degree by a 1st degree. So of course my answer should start with a 3rd degree. If I divide 4th degree by a 1st degree,
Okay, give me another example.
if I divide 4th degree by 1st degree, right? Yes, sir.
With the 2x minus 1, you said that it has to be like 1.
Yeah, so I take a 2 out.
And then at the end,
I would divide it, I would put in the penalty box a 1/2. And whatever I get, I'd have to divide those by 2 also.
why do you have to divide there? Oh, I got it. Never mind.
Because both of this would be on the bottom.
Okay, I
And
see.
again, we just barely did one example. We're going to do a lot more examples of synthetic.
So going based off that same thing, so with 2,
Yes.
if it were to be a negative 5, from that first part, then we have to divide that by 2.
Yeah, if I would have taken a 2 out, is that what you're saying?
Right here. If it was to be negative 5, then we'd still have to divide by
Yes, yeah, exactly. If this would have started off like divide by 2x minus 10. I would divide by x minus 5 and then divide by 2.
So would you do the whole process? The whole process again?
No.
No, I mean like, or do you do, or do you
This
do?
is division by x minus 5. Then to divide by 2, I just have to put everything over 2.
Right, so basically you get all these numbers first,
Good.
and then you just do them all.